This video explain finding the whether the beam is fully restrained or not, determining if the segment and subsegment. So AE is a segment and AC, CD and DE is subsegment, or you can say EB is a segment. So that's how the classification of segment and subsegment works. Are fully restrained for 310 UB bent about strong axis. Take Fy is equal to 300 megapascal. So restraint conditions are given between AC, CD and DE and EB. Loads, concentric load 50 kilonewtons and uniformly distributed load 0.5 kilonewtons. Now because UDL load is far less than the concentric load, so 0.5 UDL load is less than 54, do not consider the segment to have a transverse load. So that's the conditions. Now we will given the bending moment diagram as well, so you no need to work out the bending moment diagram. In the questions bending moment diagram is given. We have obtained the bending moment at the midpoints at this 1500 millimeters and another 1500 millimeters. So that is considering the structure analysis of the problem. Now let's say for the 310 UB32 we have a radius of gyration 32.9 from the one steel table. So if you have a 310 UB32 and line across, we will have a RY value 32.9 for this RY value. So that is taken 32.9 millimeter from one steel table. I think in the questions Fy value is given 300 megapascals. Now we need to check whether this is fully restrained or not. So segment are AE and EB. So that is the segment AE and segment EB, and AE has a three subsegments. So if you are considering AE, it has a subsegment AC, it has a subsegment CD, and it has a subsegment DE. Now first of all, looking at segments, like we have a segment EB, that would be the first check. So we are checking EB whether it's fully restrained or not. So for segment EB, we have this equation L over Ry less than 80 plus 15 beta m square root 250 over Fy. Beta m is the moment ratio. Now if this condition is correct, if true, left hand side is less than or equal to right hand side, so we do the calculations, then we said it's fully restrained. If it's not true, if it is false, then is not fully restrained. So that's the simple that we're going to check. Now this equation is taken from Australian Standard AS 4100 in page number 53, clause 5.3.2.4. we have this equation. Please note, if the segment is of equal flange I section, so therefore we are using I sections. Other different equations are given for various cross sections, but now we have given 310 UB32, so we are using these equations L over Ry and so on. So let's break down this one into left hand side and right hand side. So left hand side is L over Ry and the length is the segment, so we are working at EB. So we have 4500 millimeters divided by the radius of gyration Ry. We extract it from the one steel table 32.9, substitute that value, we get 137. Right hand side 80 plus 50 beta m 250 over Fy. Now we need to find this moment ratio beta m, which is the minimum moment over maximum moment. This condition beta m is given on the page over page 54 on AS 4100. It has given that ratio beta m is the smaller, so minimum to the maximum n moments in the length L. Okay, and the condition is positive when the segment is bent in the reverse curvature and negative when bent in the single curvature. So positive, negative plus minimum moment to the maximum moment. So that's the definition of beta m. So minimum moment, so we need to look at the bending moment diagram, and we are working in the segment EB. So the minimum bending moment is 0 here and the maximum bending moment is 127. In that case, we substitute the minimum 0, maximum 127, give us beta m value equal to 0. So we substitute beta m equal to 0, Fy 300. Now right hand side 80 plus 50 times 0, 250, Fy 300 is given in the questions. In the question is given 300 megapascals. So that's calculation gives 73. Now comparing left hand side and right hand side, left hand side is 137 and right hand side is 73. So 137 and 73, obviously it is not less than or equal to, so these conditions is false, so segment EB is not fully restrained. Now we can say that this one conditions here is not fully restrained. We check it, right? Now we're going to check these other segments now. So let's start with segment D, subsegment DE. So that is subsegments. So subsegment DE, we are going to use the same equations to check the conditions. That equation is taken from clause 5.3.2.4 on page number 53. Left hand side L over Ry. Please note the subsegment DE has a length of 1500 millimeters. That is given here. We have a radius of gyration 32.9 that we calculate, that we obtained from the one steel table. So 32.9 that's give us 46. Right hand sides is equal to these equations. Now we need to find this beta m value. Beta m is equal to minimum moment over maximum moments, and the negative values because of the single curvatures. Now that condition is given here on page number 54. Beta m is the ratio of minimum to maximum. Please note the negative when bent in the single curvature. So now we need to check the bending moment diagram, and we are working on the segment DE. Minimum is 86, maximum is 87. So we are looking only this bending moment diagram for segment DE, and we take this ratio negative because it has only single curvature. So we have negative single curvature. 86 on 127 is equal to minus 0.68. Substitute this value here and simplification Q 43. Now again we are going to compare this value. Left hand side is 46 and this one 43. They are is not less than, left hand side is not less than right hand side. So you can see here that is 46 and this one is 43. Obviously this relation is not correct. So subsegment DE is not fully restrained. So since left hand side is not less than right hand sides, you can see 46 less than or equal to 43, subsegment DE is not fully restrained. So this one is DE is not fully restrained. Now we're going to continue for segment CD. Now we done the segment DE. Now we're going to do the segment CD. Now for segment CD, L over Ry, and these equations again taken from the clause 5.3.2.4 on page number 53. We have these equations in this clause. Now left hand sides again, length is 1500 for segment CD. Check it here in the questions. In the segment CD we have 1500. That is 1500. Radius of gyration 32.9 give 46. Now the only difference here is the beta m, which is minimum moment to maximum moment for segment CD. So for here segment CD we have 43 divided by 46, these values, and that is single curvature, so that is negative, so that is minus 0.5. Substitute minus 0.5 and 300 give us 50. Now here please look at this one carefully. Here we have inside is 46, that is taken from here, and the right hand side is 50. So that makes this relationship correct. So subsegment CD is fully restrained. Now that subsegment CD is fully restrained. So that's how we make the check whether it's a fully restrained or not fully restrained. Thank you.